Today we're going to do 10-5, which is graphing square root functions. A square root function is a function containing a square root with the independent variable in the radicand. The parent function of this will be y equals the square root of x. Now first we're going to look at a graph of this parent function. In order to graph this parent function, you would do 0, 1, 2, and 4 for your x values. Now you could do 3 and everything like that, but we want to avoid decimals wherever we can. So after we've come up with this table, we would graph it, and this is what the graph of y equals the square root of x is going to look like. Throughout this lesson, we're going to move this graph around and manipulate it in several different ways, but this will always be the graph that we want to start with. Now, the value of our radicand cannot be negative. So our domain is going to include numbers that make the radicand greater than or equal to 0. So we can never be less than 0. It can equal 0, but it cannot be less than 0. So now we're going to look at solving a couple of domain questions. So, finding the domain. What is the domain of y equals 2 square root of 3x plus 9? We're going to treat this just like a normal equation, except for we are only going to use what is under the radicand to find what our domain will be, because our radicand, whatever is underneath it, needs to be greater than or equal to 0. So we're going to pull that out from under the radicand, or radical, and then we'll have 3x plus 9, and we're going to set it equal to, or greater than or equal to 0, because it cannot be negative. Now we will go through and solve it. So we'll add 9 to both sides, and then divide by 3. So x will be greater than or equal to 3, so therefore our domain is all real numbers where x is greater than or equal to 3. What is the domain of the square root of negative 2x plus 5? We're going to use this and do the same thing. So we're going to take what the radicand is and set it greater than or equal to 0. So we have negative 2x plus 5 is greater than or equal to 0. So then we'll subtract 5 from both sides and then divide by negative 2. Remember, when you divide by negative, you're going to flip your inequality. So we're going to end up where x is less than or equal to 2.5. So therefore, our domain is all real numbers less than or equal to 2.5. Now we're going to look at graphing a square root function. So we're going to start with 4 times the square root of x. Now we're going to start by making a table. So when we make our table, we're going to use points 0, 1, and 4. And when we do that, we just plug it in for x, and those are our y values that we will get. For 0, it'll be 0, 0, so we can plot that. When we plug in 1, we will get 4. And when we plug in 4, we will of course get 8. And then all you do is graph it. This is nothing new, you've done this all before. Now, a couple of shortcuts. But first, I want you to graph 3 square root of x and bring it to class. And make sure you make a table to go along with it. Now, like I said, we're going to look at a couple of shortcuts. So, when we graph a vertical translation, for example, if we have y equals the square root of x plus k, this will translate the graph of y equals the square root of x up k units. Now you might remember doing this before with different equations, and it does the same thing as it did before. So if we have plus k, it'll translate it up k units, and then if we have y equals the square root of x minus k, it will translate the graph of y equals the square root of x down k units. So, if we are going to graph y equals the square root of x plus 2, all we're going to do is move every point on y equals the square root of x up 2 points. So we don't even technically need to make a new table if we have our original parent function graphed already, which I did here. But if you do not have the original parent function graphed, then you'll want to make a table and graph it from there. What about y equals the square root of x minus 3? We're going to go move down 3 units on each point. Okay, another shortcut that we're going to look at is graphing a horizontal transformation. With a horizontal transformation, our transformation is going to be under our radicand. So we will have y equals the square root of x plus h, all under the radical, and that's going to translate the graph of y equals the square root of x to the left, h units. So this is where it gets a little tricky because it says x plus h, so you might assume you're going to move to the right, but really when it's x plus h, you're going to move to the left h units. And vice versa, when you have y equals the square root of x minus h, it's going to translate the graph of y equals the square root of x to the right h units, where you might think that it's going to move it to the left, but it really moves it to the right. So let's do an example. If we have y equals the square root of x plus 1, all under the radical, what are we going to do? It's adding, so we're going to move to the left. Feels weird because you think when you're adding you're going to go to the right, but no, we're going to go to the left. So we're just going to move every point over 1 unit, and then that is how we will get our graph. Now I would like you to graph y equals the square root of x minus 3 on your own and bring it to class for me to look at.